In our recently finished E40C sprint, Smart Assembly Quality Control, we demonstrate the high potential of intelligent tools in manual assembly. In the demonstration factory, together with our partners Atlas Copco, Capgemini Invent, Bossard Group and Miele, we invented a smart tool which is capable of identifying the current joint. This information can then further be used for automatic parameterizing of the tool or for documentation purposes in a quality management system.
We took the electronically controlled torque tool and amended it with a camera and a time-of-flight distance sensor. This enables us to detect when the tool is approaching its work position and only have the KI process images when it is necessary.
For this particular use case, it's extremely important to have an architecture that supports very fast communication in order to avoid any delays in the work process. This image shows a simplified architecture in the context of the Internet of Production. All data is sent from the bottom layer to an edge device, which does the processing and where the AI is doing the classification and is then sent further to the user interface. At approaching the joint with the tool, an image is taken and is classified. The worker can follow the normal work process and screw all joints in arbitrary order. The progress is visualized in a clean and simple user interface. By optimizing the AI, as well as the architecture and its interfaces, we were able to achieve exceptional accuracy as well as very low latencies.
In this project, we basically automate the procedure that a skilled laborer would take, which is recognizing the joint and selecting the right parameters for it. So we enabled someone who's holding the tool for the first time in their life to achieve the same work result as a skilled laborer would. For a company, this means they can free their skilled laborers of recurring tasks and use them for more productive ends.